I'm just posting that we're live and we'll get going, but I hope everyone's having a good day so far. Hope everyone's having a good day. Today, we're gonna be working on the settings. Right, we'll start in just a minute. Just posting that we're live. Posted. Closing that. And we're live there. That's good. Let's just get the chat open. Pop open the chat. Lovely. Right. We'll get going. Okay, welcome everybody. Hope you're having a good day so far. God bless you all. Today we're going to work on the settings panel. Let's just show you what that means. So we've been going fast, right? Light speed. But problems with that is that sometimes we need to just go back and reflect on what we've done and improve it. Now, why I was like, my muscle memory from Rust started coming out for a minute. Cargo. No, scripts. That was a long time ago, but it came out. Terrible. So what we have now is a sky shader which runs every frame, right, and re-renders. Not the most performant, but hey, it works. And we've got a sun now that we made last time. And you'll notice we've got auto exposure, right? So this is actually extremely bright, but there's auto exposure such that it brings all the brightness down dynamically. It's amazing. So we've got bloom, auto exposure, and some other things which are coming, I guess. And we want to be able to make it such that we can press a button. Up comes the settings. We can search something to do with bloom or whatever, and simply turn it off. Simply turn it on. Change something like the filter radius or the strength, right? Because we want these sort of debugging settings to be here and available, ready for us to, if we see a bug, right? Oh, is that bug still present if we turn off bloom? No, it's not. So it must be related to bloom, right? These such things we want to be able to do. And yes, we have code, hot code reloading. Yes, we have hot code reloading, and we also have for both CPU and GPU. But that's effort, right? If we press F1 and simply change the setting, less effort, right? It's all about making stuff less friction. This is the plan. And also got HDR as well. Hey, Bator, welcome. I'm not going to test it out. You just randomly popped up in the chat. So I'm not gonna do that. So, yeah, I don't know you. I can't trust. So I'm not gonna click on it and don't advise anyone else to go the link to. Oh, my Wi-Fi died. How terrible. Stupid laptop. I have to get Twitch on my phone soon because my laptop don't want to. Come on. All right. So, in the previous engine, right, we had this thing called the encoder system. It was amazing. Right, we've got to get Twitch up on here, damn it. Stupid thing. Right, my laptop's going away now. One day I will be able to afford a new laptop, but until then, we live with problems. What are Christian-based games? That's a good question. What are they? Well, they basically, center around the idea of spreading the gospel in some way or fashion. But obviously, we don't want to do it in that sort of like very just bluntly preaching the gospel, probably, right? Some Christian theme. Um, I don't know exactly. We're gonna get there. But the basic idea is going to build the engine, a minimal engine first, and I'm going to be praying a whole load and storyboarding and stuff to see what would be a good idea. Because you could just tell a story from the Bible, right? But then you're just telling a story and it's quite linear, right? Probably not a good idea. Maybe you set in a particular time and you're sort of just in the background, right? Don't know, or you know, but yeah. So I'm open to the ideas of things. Um, but yeah. We'll see. But, as the Bible says in Matthew 6, verse 33, but first seek the kingdom of God and his righteousness, and all these things should be added onto you. Yeah, I think we'll do a quick prayer first. We haven't prayed today. Father, Lord in heaven, we bless your holy name. Hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Today, Lord, give us our daily bread. Do not lead us into temptation, but protect us from the evil one. Help us have a fruitful time today in stream. Let's have fruitful conversation. Let knowledge disseminate to the people who are looking for it. I pray people's hearts shall change. I pray that people shall seek you, Lord, serve you, Lord, and this whole world will come to know you, Lord, as God. And I just pray that each and every one of these souls before me today will be saved before the end time comes. Help them realize where the world is going and where the truth is, even in this time where it's hard to know what is true and what is not true. We bless your holy name, Lord. In Jesus' name we pray. Amen. Rightio. How about a historic game about the missionary work in South America? Is this gonna go into Mormondy? The Book of Mormon. No. I actually don't know. I'm completely ignorant of that. Those stories. I have watched some stories to do with lots of missionary works actually. Um, but yeah, not seen one in South America. I've seen those in Africa though, and China. Ones about those, but not South America. Um, have you got any examples or things to look at, things to read? Maybe I can watch a YouTube video on it sometime. Welcome, Mr. Still. How you doing, sir? Mr. Richard. um. So, right, here we go. Yeah, so we've got this thing called the encoder system. It's pretty cool, right? Basically, it's a little custom description language for data structures, and it code gens serialization and deserialization in C. It also supports range types and bit packing. And it also supported going out to GPU, but since we're not using my custom shading language anymore, we've got to rewrite that code generator. So it's not the end of the world. It just takes a little bit of work, but it's not massive, right? It's pretty cool. It also does variable length arrays and stuff like this, right? So this is how you describe it. This is how what gets generated. So it's all really nice. So we need this. Oh, sorry. It also does bit fields like this, which is super cool, handy for GPU work especially, right? So you can change stuff very easily and it generates your macros and that. Very cool. And it also does what's the other thing? It does reflection, obviously, data type description, right? So you can say what is the type information for this, and that's what we use to do the settings, right? It also has little things to do where it would have a database and check to see if you change stuff to see if it breaks the versioning, and you can do upgrades. But if you keep in the text format, you don't have to do version upgrades. It's a lot more malleable. Is that the right way to say it? It's a lot more subject to change a lot more than a binary file, since binary is just a mem copy. This is the basic thing that we got here. So we're just going to try and bring this thing back to life. Yeah. Unfortunately, I didn't do it on the 3rd day. It's on the 7th. Is it on the 7th day? Yeah, it's the 7th day. So anyway, yes, this is it. Encoder CodeGen. Yeah. So I've not used this thing yet. We've got to plug it in. So encoder CodeGen. So it's just a silly little C program that generates C code. Right, somehow there's 5,000 lines, but there, yeah, it's cool. Does the job. Now, yeah, I think a lot of it is code generation lines. I'm not sure. Anyway, I don't know why there's so many lines of code. But yeah, so let's just get this thing compiling again. So we've got custom build script. Again, this thing needs to be sorted out eventually, but we just define like custom commands and then you basically initialize them that has dependencies and stuff like that. So what we need to do is probably make a new one of these. So a new sort of way to initialize a command. This is the encoder system. Now it would be cool if, yeah, it makes loads of little files at the moment, which is not, I don't like it, it's horrible. But someone suggested you could just make it generate into a single file kind of globally. But then I was like, that's probably a bit too much because I've got a sort of very modularized file structure. So maybe we can do one generation per module. There's something that we can move into. I'm not sure I want to do that today because that would be too much work for today. So basically we want to pass in a source path, and I think that might do it. Because we can derive the destination path from that. So we don't need any Linux Windows stuff, I don't think. Yeah, we do. So we need to make sure we compile. Yes, the program is called like encoder CodeGen. And then I don't think there's any other. What's the main look like? Ah, it's hard coded within the application. This should probably change. But then again, if we code generate a single. Yeah, I think we'll pass them in. Okay. So, we could just launch the program and then, yeah, let's just run the program. I'm down for the most minimal change at the moment. That's what I'm down for. So I think we'll just, in the build script, we're just going to have it run the program without any parameters. I just want to get it to work for now. No dependencies, dep files. Excuse me, I'm a little bit ill. Library path, what does that mean? Why was it? Name. Oh, the name of it. Okay, well the name of it is just cool. So what we'd like to do is when you change, yes, I guess the depth isn't, there's not really a depth file, is there? There's, oh yeah, you want to put in explicit dependencies. So your dependency will be, oh no. So we could just make a list, and therefore we've made a list. All right, we'll pass them in as arguments. I've changed my mind. That way we can get the dependencies working. So you'll pass them in as the input files. Basically, these are the paths. Yeah. So effectively, the way you have to look at it is, if that file changes, then yeah. So I think they just go directly into there as explicit dependencies. Then you basically just call this guy. So after we make all the directories in the build script, we pull the latest third-party folder. I've got it in a separate repo because there's only so much storage you can get on GitLab. So if you put stuff in a separate repo, you get more storage. So I've put all of the bigger binaries and that in another repo that just gets pulled. Yeah, just things, problems. So path, yeah, what path? So we probably want to put out, I think we could put a barrier down as well. So just basically stop here. Okay. So the paths, let's just get those into like char star paths, some array of some size, no biggie. So we'll lay them out here. I don't know what they are. I think the first one we obviously need to do is the settings. So let's just do that. So it's something like code, modules, settings, settings.enc. That's the one, yeah. Then array count of paths. Yeah. Now we have barrier here, so it has to do that before running the rest. Now you only really want to run this if it's changed, isn't it? If the dependencies have changed, and that should catch all of that, which would be great. Hey Orshai, good to see you, sir. How are you doing? It's afternoon here, so good afternoon if you're in the afternoons, and good evenings if you're in the evenings. Hope you're all having a good day. What stuff have you guys been up to? I'm looking for the order H. There we go. So basically, I just dumped some stuff in here, like, you know, platform code and all that. Be alright. Right, so yeah, that's good. So we've got to change this now such that it actually puts this into here. So we're gonna have to keep appending and appending and appending. Yeah, so we probably want the command to be like this. And we just want to keep append. So we'll say, you know, I guess we'll do it'll be slower, but it'll be fine. Index equals 0. So index plus equal sn printf. Command size of command. Then the string would be and the string would be, I guess, command path. And you could do it some other ways. Maybe we should make a thing that just appends. But anyways, printf. We'll do it. We want to do this. Oh wait. Slightly wrong. That would have worked there, but when you say offset by index, take away size of index. So now we can copy paste it for the future. and go over all of the paths. So it's from I 0 paths count. And you're just appending paths. Now, the one thing is you do want to put a space before everything. Yeah. Then output the command into there. Voila. I didn't get my full range loop in here, so let's quickly go and get that out. I'm from across the pond. It's barely breakfast time here. Yeah, so you're in the United States, I imagine. The land of freedom. Bum, 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 bum. Cool. So that looks sensible. So now it's going to call that program with the settings encoder file and hopefully code generate that. Yeah. Now the issue is we haven't actually compiled this program, the CodeGen program, and we haven't made it such that it takes the input parameters. But not a biggie. Now the problem is this was kind of including some of the encoder system stuff, and I had to include the it's horrible. I had to include too much of the system. But I kind of needed it because it made it a lot easier to work with. Like I could define my global array stuff, right? So I think something needed the asset system as well. The encoder system needed the asset system and stuff like this. It's yeah. I think it's okay. I don't know if we've got the asset system working yet, to be honest, but we'll see. So yeah, let's just keep with this and hopefully it works. Now, the problem is though we don't have game main anymore, something, is it? It's for declared but not needed anymore. You define your own main these days. And you're going to say, basically, give me all of the paths. So for range, yeah, index 0 or 1, because argv0 is the command itself. And then we're just going to throw in there argv index and voila. Beautiful. So now the next thing to do is to make sure this program actually gets compiled. So we need to run build an executable. So I think it's this one, Clang exe. I think we need to put a barrier down as well. So so that'll be apps encoder CodeGen, and we just want to make the encoder CodeGen executable, right? And that should just do it there. I think we need to put a barrier down. Yeah, the system needs to be done properly, but we're just sort of going in a direction, see what we need as we go, and then there'll be a rewrite which is required, right? But until that time. Adrian Dad Hype, how you doing, sir? God bless you. As someone used to reading maths books, how do you retain vast info about computer science books, which math I can always prove myself with computer science non-proof books. Yeah, easily. I'm not sure really. I don't really read books, so I just get out there and do more practical about it. More on the practical side of things. I read the odd blog post, but it's just practice really, get out there and doing, thinking, lots of thinking about things, how could I design this thing? Oh, would this be a good idea? Go out and try it. Turns out it's not, right? That sort of thing. So lots of just trial and error and practice. Get in there and do it. That's the way I've always done it. Right, so if we see the build script now, if we run it, what happens? Right, so as we see from here, it tries to compile the encoder code generator, finds out there's a problem because it now needs a custom allocator. So this is cool. We're going places, and it didn't try to put the rest. Oh, there's a to-do, isn't this funny? So, right, lovely. So we want to pass in the allocator. What's an allocator? Well, we could just use the red stack allocator like this one. But then we have to make sure we initialize it. Do we still have a crash handler? We do. Okay. We have a new handler. Right, so we just want to make sure we call core TLS init, I think it's called. Yep. So what's the size? I don't know. 8 megabytes. Is that enough? Or core megabyte in it? Yeah. And then I guess we'll just do 0. Okay. Here we go. Someone's telling lies again. This is what you guys do. You just spread lies. Anyway. Just move this guy out. Not true. Muslims and trans people, all people, guys. I don't know why you guys say I hate these people. It's terrible. Literally. So, right. OS file read all. That should have compiled. So I think the barrier that we've put in is waiting. So we go back to the build script. Then what we see here is, yeah, we put this barrier in and I think it's waiting here on all this previous word to finish. If we take this away, it's probably going to work. But, oh no, it's this one here it's waiting on. Yeah, we've got to step in here and find this. So, this program. Nice. So add target. Oh. Build. Build script. That's the one. Right, so we run it. Hmm. Can we see any output? Panels. So I'm not sure where we can see the output of the program. Strange. Oh, right, there's an output window. Right. Hmm. Okay, maybe this isn't right. What's going on? So the working directory might be wrong. Perhaps that's it. Yeah, I think that's what's going on. Let's see what the script says. So if we go to scripts. I think it's build. Right, it says compile the build script and then run it from this directory. Yeah, that's right. Okay. So my current working directory is just a little bit off. Deletes the whole thing. Terrible. Oh, help me out. Cool. Right, let's give that a run. And voila, it works. There we go. So, yeah, now we just want to stop inside the file. I'll try and open that file now. So, we're going to try and open in code, apps. Build script main. Right, so basically what this does is this assigns these, like, every time you do command in it, it just depends onto an array in the background saying, run this command, right? And then when you say watch, it's going to actually go and do all of the work and then sit and watch to see if anything changes and then do all the work again, right? Now, yeah, it's a very simple system, probably needs to be improved in many ways, but it does the job and it's working for now. So what we need to find out is why does it stop on the barrier, I think is the question. So barrier would initialize a command with everything 0. Then it runs this barrier thing, right, where it waits for the process IDs. So maybe we should put it in build run Maybe this is it. Yeah, so build run is like a common abstraction. Yes, it's probably... Yeah, so we can just put breakpoint and build run. Okay, so let's have a look here. Build run. Build watch. Okay. Okay. We don't even get into build run. How? Very bizarre. Okay, well, we'll just go to watch then right at the bottom. Are we looking in the wrong... You know, it's not got debug info in it. That's why. Right, so scripts build. So I guess we need a -G here for a minute. Then we can run out the debugger. Finally, this is what we want. Right, let's just go over the array commands, right? Nothing too hard. So if the command is that means it's a barrier. So we run, if dependency has changed, yes, run it. Second one, it's a barrier. So you get into here. So go over all the processes which are still running, check if they're done. Ooh. Yeah, so no error. What do we do about the processes? Should we set process count to 0? Yeah, it does. It does. Good. The process count to 0. Success. False. Yeah, so it doesn't save a... Right, there it goes. And watches. Interesting. It gets stuck. Oh no, it doesn't. Where does it get stuck? It goes over all these paths. Does it ever escape? Does it ever escape? Oh, it waits on the completion port for a file to change. But we've just waited at a barrier. Right, I see what's going on. So it seems like we just waited at a barrier, but it exits out of the function too early. So if we go to build script main, what we find out we run if success, we run the auto run, which runs the game. If not, we basically check for all files and wait to see if they've changed. So here we don't want to exit. That's the thing, isn't it? So why is it breaking out? Right, so how can the barrier... Also, if the barrier fails, then success, false, and break, I guess, right? But if the barrier fails, then... Yeah, the program failed, then wait for a file to change, yeah. So I think it's a not equal there. And then if not, continue, go to the next. Yeah, I think it was just the wrong, a Boolean logic, right? It's just the wrong way around. Happens all the time. Yeah. So that seemed to have run the game. So it compiled the code gen, and what we'll find out is that it didn't run anything else. Why not? So it would have been successful, continued to the next one. It should have run more commands, but it didn't. Maybe because of the timestamps? I don't know. But we can easily just, again, go back into... Right. So we want to run this, and then run it in rad debugger. Let's do that again. So we want to get him run. See how that works. It runs the first command. Apparently it's got like 176 dependencies. That seems weird. Why has it got so many dependencies? Let's have a look at that. Wait. Oh yeah, that's to compile the... Yeah, I think this is fine. No. These things have to compile first. Oh, no. I think it should be fine. Yeah, in future we might want to link the files in. Okay, it's fine. So I think we can skip past that basically when hit that. So we want to put a breakpoint here instead. So skip the first command. The second command should be a barrier. It was successful, so continue around. The next one is a command. This command is actually do the code generation. Now, what are you saying? It's got dependencies, right? So it's saying that the file hasn't changed, sad. So I guess what we'll do is we'll delete the the timestamps file, or whatever it's called. Maybe build timestamps. Get it to all go again from scratch. That's a lot of stuff in here, isn't it? Maybe we should just get rid of the build folder. Let's just get rid of the build folder. We don't need it. All right, let's go again. Here we go. Oh, that's great. Amazing. So what happened? So we see here that it went here. Create a library. Then it built the game. Then it built the shaders. Seems a bit fishy to me. So the encoded code gen's right here. I don't see it saying .lib anywhere. Oh, there it is. Okay. Anyway. So why didn't it run it though? That's the question. Bit bizarre. It's linked against that Vulkan and all this. Okay. But it will do. Yeah, I think it's probably going to complain again that the timestamp, something to the timestamps. Let's have a look at that. It's bizarre. It's rather bizarre. Right. Okay, so we delete all the build. Now we're running Rad Debugger. So let's see what happens here. Oh. So we need to build, but not build the build script. Right, can I yank this? Cool. Let's run it here. Right, so the first one runs, that's great. The next one's a barrier. Next one should be the other command. It's got dependencies. Has it changed? So it's saying it's not changed. Why would that be? So we've got the dependencies would be, let's look at these dependencies for a minute. So the dependencies are the settings file, but where's it? So I guess it queried to get its timestamp. You got to initialize at some point, basically. All right, let's get back into the editor. I think. Yeah, so when we made that new command, which is this sort of, yeah, so we compile the code generator, put a barrier down, just because it needs barrier. And we're trying to run the code generator with, say, hey, start this settings file for me, and perform code generation. It puts this as a dependency, but then it sort of gets a timestamp for it or something like this. But then like there's no depth file to be passed. So essentially these get added on to become dependencies at some point. The parse depth file, well that's going to get the explicit dependencies, okay. Normalize the path, put the dependency on, dependency hash, and do a timestamp update, right? So this is going to say it does a stat. If it does not exist, put it in as the current time. So that means what we've gone and done. Sorry, if it doesn't exist here, insert a new entry with the last modified time as this. Success modified time. Interesting. What are the differences? So if it's changed, yes, I think we want success modified time in that function. So success is like, you're not really using success. Yeah, that was silly. We're using it. We're kind of using it, but we should be using it in another place. So where it's using that sort of latest modified time. Yeah, what's update doing then? So when you make a new entry, yeah, if you test if a file has changed, Oh, no, we are using it. Oh, crap. Oh, that should be evaluating as true then, because the success should be 0 and then later should be set to a file time. So when is that getting updated? Right, we can look at that. Right, let's delete the timestamps again. We got any timestamps? All good. Man, I hate when I have my laptop working. Just complaining about, oh, this is, alright. So, when we make the command, I think that's the best place to have a look at. In this particular case. Initialize the command. Now, we parse the deps file. There is no deps file, but we put it in here anyway. So we say after you finish parsing it, take the explicit dependencies, normalize the path. So it's the same one, it's just a full length. Hash it, update the timestamp that we have for this dependency. Does a stat, shouldn't find it, doesn't, inserts a new one with the success modified time as 0. Right? Cool. Deduplicate, I guess. Oh, crap. Right, so I think that's reasonable. So when we go to run, this should be the barrier. Yep. Then this is the actual. We're checking to see if the dependency has changed. So we go into here. Right. So the path hash is different. Right, the path hash is different. Oh, it's going over all the timestamps. Okay, so we've got a lot of timestamps, so we may be here a while, but let's put one here and then here. Cool, so it did hit here first. Now we get the timestamp out. We see success is this. So when did that happen? It's so bizarre. When did it decide to set success equals something else? It must be calling. It's so bizarre. All right, so what we so it sets success when what? When we do commit. Okay. So us after a barrier it calls commit. Ah. So commit is going over all of the timestamps and saying, yeah, they built fine, which is wrong. Okay. Right, we found the bug. So how do we fix it? So commit should happen only up to if all of the commands which have run go over all of those dependencies and commit their timestamps to saying they've been built successfully, right? Yeah, that's what you're really looking for. So when you're talking about these build processes or whatever, ones which have ran, you do have a pointer to the command. So in turn, we can actually pass in the processes. Gbuild processes, maybe we can do it in there, I'm not sure. I think we can do it. Cool, we can. Right, so gbuild processes count. Command processes. Process, call it P. Now we get the command C. Then we can say we want to find the timestamps. So you need to go over all the dependencies now in where do you say, yeah, path hash, isn't it? So you want to locate the, go over all the timestamps, locate with the path hash. You go over all your dependencies. It's super dodgy, but okay. Is there a function that finds the timestamp? No, apparently past me has not done it. So present me is going to carry on. So go over all the dependencies in the command. I guess we'll call it command. We want to then go over all of the timestamp commit, I guess. You do the path hash. Go over all the timestamps and then commit like so. Lovely. So I think we're still at that. It's not the best code, but it works. So command dep hashes. Cool. So that should do it. Let's give that a go. Right, so close that. I don't think we need the debugger anymore. Yes. Running EC ENC, so encoder code generator. But then it got asserted. What a shame. Guess we need the debugger again. Give it a run. Huh. Yeah, you can't do breakpoints in macros, obviously, but it is worth a try. We can breakpoint on the exit, maybe. So you could put a watch add function. So we just do exit. Let's try that. Lovely. So we got this here. Failed to execute empty string. So that would have been the yeah, that would have been the barrier. No? Oh, command was empty. Oh. Okay. Maybe not then. Right, so when we did this new sort of like, hey, the encoder system, you know, generate that. Maybe it should be called encoded code gen, to be honest. A little bit better. What we find out is that there's an actual command in here. Oh, it's on the stack, isn't it? Great. So we want to make sure we string clone it, I guess. Yeah, so I guess let's call it string format. So we'll do char star command underscore equals string format. So just clone it, basically. That's the reason why. Right, so now the code generation thing is failing, so we shouldn't have to touch the build script anymore, I hope. Oh, that'd be really cool. So build.bat, get rid of this G, and I'll need to debug. It'll take a bit longer. So hopefully close that. Now in the encoder system, there's something that was kind of a little bit wrong. Is we used to pass in a path which didn't include the suffix or the file extension, right? So what we need to do instead is ensure that this path has this file extension, then copy it to do this encoder database one. Yeah, just stick that on the end. Oh, you know what? Just stick it on the end anyway. Yes, the encoder path. What's this file name thing? Oh, I guess the file name. That's kind of nice. Yeah. So we still want to do that. Then we want to get rid of this and make this just append database on the end. Nice. So there'll be a generated. So I think we'll have to do a dot star on here. Then string, I guess. Oh, so we just have to basically encoder path string dot size, encoder path string dot data. There we go. Lovely. So that should be the fix. So notice there how it, when it recompiled the executable, also recompiled the settings, which is great. I tried to rerun the code generator, but it's still failing. I wonder why there's an exit code. That's horrible. Let's have a look, shall we? What ways are there to exit? You would see stuff being printed out if it's a problem. Let's try and run it through rad debugger, I guess. We need to make we should really compile it with debug settings, but I think it's already done that. Yeah, it's already got -G in there, so it should work. So that would then mean just adding a new one of these basically, so we dupe. Encoder codegen.exe. Lovely. So oh, we actually got an assert. It crashed, I guess. Page size is 0. So we need to initialize the OS pre-init first. Needs to happen. Mm-hmm. What was running? Apparently. I don't know if that's true. It must have stopped, right? Oh no, it's still running. Oh, it crashed. Okay. Well, we run it again. No, 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 no. Hmm. Right, here we go. So, how many transics type? 45. Doesn't matter. We'll skip here. Right. Oh, interesting. So it didn't... Wait, why is there only one argv? You gotta be kidding me. The reason how it works on Linux. Oh, likewise. Right, so apparently... Oh, right, of course, because I've not done it into... Let's go to the build script. Let's fish out the path. Testing purposes. There we go. Cool, so we're able to get here at least. Infinite run. Right, let's debug that. Hey Buffer, how's it going? Hey Davos, how's it going? New engine, kind of. We're doing a reboot. Lots of stuff is still carrying over, but also lots of stuff changed. So you can check out. It's probably only going to be up there for 2 days. You've got all of the FOMO, but you know, fear of missing out. It should be available on Twitch. I don't know if it's still there, but it should be there for 2 weeks. So it's Sunday the 1st, that stream. You can check it out and get caught up where I've been, what I've been doing, and what's the plan. But yeah, we got yeah, so I won't spoil anything for you. But I'll happily answer any questions if you got any. Welcome Buffer Overflow, how you doing? Hey Zaka Zaka. Trying to get my code gen program working again. It's nearly there. Right, so what we find out is... Yes, that's good. DB. Oh, we didn't make it end in .enc underscore generated. That's not what I would like. So that's something we can start changing right now. The reason why I got the size is so I could take away 4 characters. Size of... I'm hoping this works. It does, of course it does. Yeah, so that's something to start off with. Right, so are those in a good place? There we go, settings underscore generated. I'm hoping to put it all into a single generated file, one per module, but for now it's going to be in one file gets you a generated file. So parse this file, right, we parse the database, it spends forever apparently waiting there for some reason. Where are you? That's the question. Deep down in the OS. Oh, getting a stack trace. Why are you aborting? Out of memory? Sad. You're trying to allocate more than 8 megabytes. That's why. But why is such a problem? Oh, it's recursive. Isn't that lovely? So try to how long that stack is. Ooh. Right, so it's tried to do a printf. Oh, exit reader error. What allocator are you using? The frame allocator? Printf. Frame allocator. Right, gotcha. Alright. It's 0, if you didn't know. Let's make it 8 as well. Right, so error identifier must be. So this is trying to parse the database. So this is getting good now. So settings dot encode. This is the thing for now. I want to change it anyway. Code, modules, settings. So the basic idea is there's a settings system which is kind of like plain old data in a way, right? It's just data that lives in a module that every other system can have access to, and its main purpose is just to render a UI that allows you to change data, right? And then every other system can read that data and be like, oh, you want to turn off Bloom? Great, we'll turn off Bloom, right? But that's all that it's for. It's not meant to be anything else, I don't think, maybe. Maybe I might try and make a way to issue commands, like actions. That's all it is. So we've got this custom file which allows us to put these settings in. Yeah, so basically get type information and all this and automatically make all the UI for the settings, and that's all it does. So we want to delete these and do it from scratch. Now, anti-aliasing we don't have at the moment. Occlusion we don't have. We can always add this on. Tone map. That'd be a good one. None or GT7. You know, we could do different things. We could do exposure or EV. You can't do -1, can you? Yeah, I'm trying to think. You could do, because if you did like -1, maybe like half, quarter. So we could call it yeah, but you've already got exposure anyway, so I think we can just use exposure to do that stuff. Cool, got bloom on and off, obviously. Yeah. So that could probably just be a toggle at that point. The reason why I've got a separate enum for that is so it code gens. So field of view, that's a fun one. We want exposure as well, you know. We got bloom. Bloom filter radius, interesting. We should probably have a default on that as well. Bloom strength. Yep. We need to do lighting in the future. Okay, so what we wanted to add, which would be really nice, is what is your sort of exposure in, right? Do you have auto exposure on? I guess you say auto exposure or manual exposure. Exposure mode. Yeah, is it? Right, exposure mode. Auto or manual. Never metal. Yeah, fun. So exposure mode. Now, if you have manual exposure, what you would like is to manually express exposure in EV100. I don't know what it is though. EV100. Yeah, it's exposure value, right? So, but what sort of range is it? I forget these things. So one stop. So EV1, +1 or -1 would basically half or double the actual luminance every time. It's powers of 2. Yeah, it's non-linear, but it feels linear perceptually. Yeah, we have the code, right? We could just look at that. So that is in shader. Right, EV100 from average luminance. So you get the average luminance times 100 divided by 12, then take the log 2 of that. Right. And then we're using the EV100 to get exposure. Turn that to exposure value. Or did I say EX? Oh, that's a mistype. Don't mind me. There's max. Right, 2 to the power of EV100. Then inverse it. Right, I see. Okay. So if we have, let's try this out, right? 2 to the power of 1 is 2. 1.2 times 2. Oh, I've got to get a different calculator. Right. 2 times 1.2. 2.4. Now, you would then do 1 divided by 2.4. Right. So that's just for an exposure value of 1. Yeah, so I wonder what it would take to get it to be basically nothing. So he's an exposure value of 10. So, well, probably a good one. Let's do every time it doubles, maybe. So let's do 4. So 2 to the power of 4. 2 times 2 times 2 times 2. Let's write it. We get the science one now. 16 times 1.2. 19.2, so 1 divided by 19. Oh, it's going to go even lower, isn't it? Of course. So that's not good. So your f-stop needs to be, so if you did a minus, Right. So you needed like a negative or something like that. Maybe. Right, so when... okay, so it's got to allow us to go into the negative. So let's just say -5 to +5. Maybe. To +5. So this would be manual exposure. Manual exposure, EV100. Okay. So what other settings do we want? We want to also allow for some kind of bias. Right, so auto exposure bias. So a way to offset the EV100 as well. That'd be kind of useful. So obviously got bloom. We've obviously got the whole bloom settings, which is super cool. And I think those are it. There might be some other ones, but let's just get these in. These would be fun. Cool. So apparently that compiled stuff. Apparently compiled the code generated, that's for sure. But it's also done... Right, it's done this sort of .enc thing in the code gen, which is not nice. So let's delete these and go again. So that would then mean in the code gen... Right, when it's done this name... Obviously file name includes the extension. So we could say pop extension, and give me the file name. That'll work. Cool. Lovely. Right, hopefully that works. Oh. Okay, just compiled it. That's not nice. So, why? Why did it do that? But, right, so things seem to be... Oh no, it's in an infinite loop. Don't do this. There seems to be some case now where it infinitely goes round in a loop and tries to compile again. This is not fun. But it seems like we're there though. Right, it doesn't seem to commit it, or... But yeah, here's the settings now. They work. These are the new ones, you can see them. So we should now be able to change the wire these in, which would be super cool. You know, just basically type in here, you know, I want to change exposure. Yeah, let's work. 2 seconds. Oh, young man. Bye. Apologies, my son wanted to say hi. It's so much fun. Love that boy. Man, children are so innocent. They're great. But yeah, so we want to make it such that it's a very little keyboard. It's a key. We want to make it very usable from the keyboard, right? You press F1, right? You can just type away, use the arrow keys, and get in there, right? Obviously, it's all fuzzy search and all that, so it's very easy to get to where you need to go, and rather than type in every specific character. That's what we want. So that's what we're going to try and drive to today. So let's actually wire up the settings, and we'll make it feel nice. I don't know why. Oh, okay, so So we're going to wire up the settings. That would be in graphics VK. I think we just need to include settings.h, I think. So it's nothing complicated, guys. It really isn't. It's just literally you got the code generated file that it points to, right? That's just a global. You can just read it, access to it anywhere. We got some macros to help get and set based on the ranges and stuff like that, so it stays clamped and all this. And it has ways to sort of encode and decode from the actual text file. That stuff to I'm not sure I've supported saving it out to a text file yet, but it's all there ready to go. I've just not done it from the actual settings system yet. The settings system is very simple. Again, it's just you initialize it, right? It loads it all in from the file and, you know, initializes the UI stuff. You know, gets all the type information for it ready and all that, I think. And then you just render the UI and it just goes over, you know, makes a new panel, puts the filter at the top and then goes over every single setting and, you know, does it based on the type information that's available. That's all it's doing. There's a new list and all this. And, you know, I've got some keyboard stuff in there to help navigate. Now, so we just need to go into here where we do all this exposure stuff and all that and let it work. Oh yeah, the exposure, you want to change the bins. You know, this sort of min log 2 luminance and all that stuff, right? So settings.enc. So it's like a min. So min log 2 luminance, what do we have it at? I don't know, 0 to something. Yeah, 0 is probably sensible. Maybe all the way up to 10, I don't know. So exposure min log 2 luminance. Min luminance log 2 maybe is a better way of saying it. Then the other one is the luminance range. So how far did that go? Just 6 in log 2 space anyway, isn't it? Yeah, so up to 10 maybe. So we're going to default this one to 0 and default this one to 6. Yeah. Then these are auto 0. Obviously auto exposure is the default. And then, yeah, that's kind of nice. So I'm going to regen that right there. It keeps recompiling everything now. This is an incredibly terrible bug, but we will look at that in a minute. I don't think it's committing the timestamps anymore. Very sad. We can prove that in a minute. Oh yeah, in a minute we'll do it. So settings. No, sorry, not settings. Graphics. VK. So right in here, this to do whatever. Oh, there's a pixel discard ratio. Put that one in there quick. This is a real good one. 0 to 1. Discard all the pixels. Anyway. 0.1. Right, so that's done the code gen at least. Right, so we're going into graphics VK, and then we're gonna get rid of these. So, right, so G settings dot graphics dot exposure min log 2. Lovely. Then 1 divided by the luminance range. log2, because we want it to be inverse for this gather shader, so it just gathers all the pixels, puts into a histogram. I wonder if we can do, we want to put the debug. Yeah, I think we want to put the debug visualizer on as well. Let's do that in a minute. That's another one to do. Then the range, but without the inverse, it's just the solid range. Then we want the pixels to discard. Ratio, so discard, oh sorry about that. So discard from the histogram, you've got the most brightest pixels and the darkest pixels, get rid of those, eat from each side basically. So I think you should go up to 0.5 really. That's a good point. The pixel shader is a bit wrong. Sorry, not the pixel shader, the compute exposure shader. This should, when it's doing pixels to discard, it should be half. Oh, excuse me. Ooh. So pixels count, the discard ratio. I guess we half it first. Lovely, 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 lovely. Cool. So we get rid of these things now. Amazing. I do want to probably add another one. So inside exposure gather, we've got this lovely. Oh, sorry. Inside exposure compute, we've got this lovely debug stuff. So we probably want to have a way to compile this out. So maybe we'll just have it behind an if def debug thing. So if we see in the build script, maybe what we should do is in our shaders, pass in some kind of debug. So we'll call it flags, I think. Obviously, right, if def debug, right? Yeah, so I think I'll just go. There's another one here, so wherever that is. So 1, 2, 3. 1, 2, 3. So here. So flags. Lovely. That's what we want. Need a space in here though, obviously. Now, so that will mean then in all of our shaders we can actually just put stuff like this behind an if def debug. Rightio. Now what we want to do as well is inside, we have a compile time thing so you can actually strip it out at the end, but we also want to have it as a, actually I have it as an if statement. So inside shared, where we do the push constants, these are passed from CPU to GPU in the command buffer when you dispatch a pixel shader or a compute shader. Now, all we're doing is passing in a boolean, say show debug, like so. So here we can add a new one called show debug. We can't have booleans passed up because they're an unspecified number of bytes. Okay, so again, we need to quickly put that in the settings. So it's something like So show debug, and by default that is going to be false, right? We do not want to show that. Oh, it's going to be awesome. So I think we can maybe just test this one out, see if it works. Exposure compute. So here, if PC, so push constants, show debug, then in GLSL, because it's not Boolean, you have to do the Boolean conversion manually. And voila. So we try that out. We could put some more of them in places, but it doesn't matter for debugging, right? We could put them around here and all that, but we'll just let stuff like that happen and it just be compiled out when we compile without debugging stuff. Okay, very nice. It's got to compile everything. Got to fix that. But there we go. Here we go. So we can now go down to exposure, show debug. Right, the arrow key thing is messed up. That's not working. Right, so we can't toggle anything, but we can change the min log luminance. Look at that, it's responding. We can change the range, the bucket range, and we can change how many pixels it should try to discard from the top and low bins, but we cannot obviously see this happening because we can't get the visualizer going. So we'll see if we can do that quick. But yeah, very, very powerful. It makes it, you know, there's some cases where hotcode reload is great. There's some cases where a settings panel does the job much better. It's more interactive. But yeah. Cool. So what's the next thing? So inside that settings. So we're basically, you know, it's a little custom UI thing. It has multi-window and all this, right? Is immediate mode UI. We do a list, right? A list of all the settings. Now, when you're in here, you compress things. What can you do? You can press arrow keys. I wonder where that happens. Yeah, if up, down, that has been pressed. So enter used to means you could go into a mode, which would make it a small window. But I remove that since I don't have single window anymore. Right, so what we want to be able to do is make it such that there is left and right. Interesting. Ah, to do. Right, it's all here ready to go, apparently. So we need to pass in there's another parameter, it's like an OS packet. So I've already gone ahead and done this since in the previous engine, where I've moved all of the input into some sort of like packet. And this means, so you say virtual keyboard. This means that when we do multi-threading, it's going to be better because we just pass around a previous state's worth of input packet data. Like, hey, it's got all the mouse and keyboard stuff in there. Completely, you know, it's for that thread or those threads to work on for that frame. Yeah, so it's very cool. It's no longer a global, basically. So we've got this left right thing and it helps us change values and stuff. This should help. Right. So here we go. Oh, show debug. It works. Yay. So you can sort of see it. Basically, what you see here. Hang on a minute. Do you see these colors here? The problem is that the exposure dims these debug colors as well. It's really annoying. Yeah, it's actually a very annoying thing. Can I try and hang on a minute. I would love to see if we could put this debug drawing here. If that could possibly be done. Can it be done after post-processing on the post-processed image? That would be cool. But then it means... Yeah, so I'm going to try this one out. Yeah, scene shaded image, this one. So rather than the scene shaded image, it'll be the post-processed image. Let's see if that will work. There might have been a problem with that before. But it would be better. Because then when we do the debug drawings, it actually... Yes, so now the colors show up properly. So here they are. These are the histogram buckets. So for some reason, there's a lot of them going in the dark pixels, but they get discarded. I guess that's these ones down here. But yeah, there's only so many in the light ones. So it gets rid of like 10% of the overall pixels, which are in the low side and the high side. So it takes out the complete dark and the complete bright, because those are outliers and can cause something to sway too far. Say if you get some very bright spot, which is only a few pixels, yeah, those don't mean as much, basically. It's overall what is it on average, basically. So we get rid of the outliers. Now, you can increase how many of the outliers it gets rid of. As you can tell, it gets darker, right? Because there's less bright stuff, I guess, and less dark. True. Then we can tweak the luminance, the min luminance. So this is the min luminance. Here it will change. When we change the min luminance, the higher it goes, the darker it will get. That looks nice. Because more of the stuff stays darker. Or more stuff goes into the darkest bucket, basically. Then you can change the range. So it's at 6 in log 2, which is 64, I think. Luminance. You can change it, right? So see here at the bottom now it's changing. As I move it to the left, more stuff goes into the bright side, therefore making it brighter. When there's more range, more stuff goes towards the dark. That's pretty cool. Now, we want to also add manual exposure. Manual exposure will be very useful because we might just want to debug stuff. And we might want some scenes with manual exposure, I guess. So let's just put it in. It doesn't take too much work. So when we have exposure, we basically do not need to do this. If we have the if not G settings graphics exposure mode, if that is not equal to, I guess it's like V0, I think it's called V0 settings. Come on, pick it up. Maybe not. Hang on a minute, let's get in there. Settings dot generated. So I think it's like Exposure mode. These are graphics. Yeah. So it's not equal to automatic. We just want it to end early, right? Doesn't need to do anything. Then what we need to do inside post-processing. Now we could actually put some of this stuff in on the GPU. You know, we have got ifdef, like ifdef HCC. That was my C compiler, which I've kind of parked at the side for a minute. So I tried to make it, yes, shareable between CPU and GPU. So this could really be shareable and just parked inside a buffer on the GPU. Then you just basically go, you know, I could make a macro called S, and you just say S, and then put whatever is inside the macro thing, and you can access any of these, right? We could do that. That would be awesome. And then you can get access to everything. And then you won't have to pass it in anymore. You know, I'm going to live with passing it in, it's fine. Yeah, see, this is where we should probably get it to work on GPU. Yeah. Because a lot of this stuff has to... Yeah, we should probably change this just to be a bunch of macros, basically. Get rid of the type defs. Do the def strut thing. Man. But yeah. It's possible. It shouldn't be too bad. But yeah, we could make that change. Because I guess we cannot do... We could pass it all in manually. We could do like an manual exposure thing. There probably isn't that many settings, to be honest. So yeah, I think we can live with the friction for now. Yeah, let's live with the friction for now. Hey, Psycode, how you doing? Are you using a 3D LUT aerial atmospheric approach for the skybox? Hey, good to see you. It's been a while. No, just I think I can show you the one I use. So sky. This is the one that I used, but I also added a sun. Yeah, I also added a sun to it as well. It's pretty cool. It basically does some spectral rendering stuff. Like if you turn off the spectral rendering, it doesn't look as good. It does some multi-scattering thing as well. It's pretty cool. But yeah, so it does ray marching against the atmosphere and stuff like this. It's got different aerosol types. I don't know what this would even mean, but yeah, these different parameters basically. It's kind of physically based. That's the idea of it. It takes a couple of milliseconds to compute, so it's not the best in terms of performance, but it looks really nice. So I can maybe reduce how the frequency gets updated every frame, or maybe things to think about. You know, change the resolution, right? Update parts of it, but not the whole thing, right? You know, you could do tiles, right? Do a tile every frame, but and hopefully you won't see a seam, right? Stuff like that. But yeah, it's fun. I see. Yeah, so that's yes. This one does array march and yeah, it's using that the papers. Yeah, it links to the papers that it's referencing basically. Yeah. So there is the... Is the 3D lookup table sensible though? That seems quite a lot of memory. What sort of sizes is it? What's the dimensions? Yeah, ozone scatterings. Yeah. That's it. Yeah, that's cool. Yeah, it looked really good and it looked kind of modern, like recent. So I was like, this is the one. Shared. So we'll go to the post-processing. We'll just pass them in here for now. I don't know. We'll just pass them in here. So I think we might have to have some flags. It's kind of better for performance if they're passed into the push constants as well, so... Yeah. Oh, we don't get enums. Joyous. Flag. The flag is HDR. Auto exposure. How big is like the 3D lookup table? If you were to sort of, I guess your you'd have to array march, wouldn't you? What's the? Weird. So, oh, it's only 64 squared. That's not that bad, is it? Is it like an SDF or something like that? What is it? So we're on like an auto exposure flag. I don't know what else, but that just saves us from going over too far there. We want another float for like some kind of exposure. It could be exposure bias. We can call it like exposure EV100. Right, so bias for auto exposure. Okay. Manual exposure or bias EV100. Just put it in the name. Yeah, then a tone map mode. I think in that case we'll just say basically tone, you know, do you want a tone map? Right, I might want to turn that off just to see what it looks like. It's not SDF. Let me see if I can find it for you in a sec. Cheers. Thank you. Thank you. Appreciate your hard work. So if we go into post-processing now, we can work some magic. So this is the auto exposure EV100. So we want to say, right, if BC. Actually, we probably shouldn't work some magic. That's a sin. Switchcraft. Magic is forbidden. We'll work some science. EV100. Right, flags. Oh, this is GLSO, it's terrible. And hang on a minute. Auto exposure. Not equal 0. Then man, languages that make me do this. Then we use that. If not, my EV100 is from the push constants, and it is simply manual exposure in EV100 or a bias. Now, the interesting thing is we could initialize it with this, and then accumulate with that, get rid of the else. Bam. So then we turn the EV100 into a exposure, multiply on the color, up, done. Now here's the tone mapper. Alright, so this is the paper. Nice. Oh. Yeah, if something graphics related isn't done by a Sebastian, you can't trust it. There always has to be a Sebastian in there, if not, not be trusted. It's a very common name in graphics programming. It's amazing. All right. Well, that looks lovely, doesn't it? I'll do it on mobile too. Cool. Renderings of images, different atmosphere conditions and viewpoints using the method presented. Oh, they do it from different viewpoints as well. So you can do it. So you're telling me there's... Excuse me, I'm a bit ill. This can work on planet and off planet with the same code. That's fun. Man. That's cool. Yeah, Sebastian Alton, or if you pronounce his name. Alton. I don't know. Yeah, that guy is quite... I swear, like, he's always on his phone. Whenever he gets an idea, it's like, right, this needs to go on Twitter or X these days. But yeah, he's got some good content on there. I'm not knocking his content. I'm just saying he manages to write so much. I don't know how he does it. He did that GPU, no GPU API article, didn't he? Hopefully that's enough to push it in the right direction. You just sell building Raymarch is the output lookup table. Right. Nice. What's the advantage of the lookup table? Just you don't have to Raymarch anymore, right? So therefore it's cheaper. Yeah. What are the downsides? That's cool. Nice. Off planet is a 4D. 4 dimensions. 3 is already too much. Oh, so HDR. Do you want HDR on or not? So tone mapping. Do you want tone mapping on or not? Right, so I guess you can skip this whole bit here. A whiff statement. Yeah. Smells a bit funny. The codes smell a bit funny. Right, yeah, we should probably make this tweakable as well. Just maxed it out. Right. Cool, so we could just simply pass those in now. So let's go and do that. So graphics VK. So in the post-processing, we just simply put them in. So we need some flags. So flags. Oh, you always want to make sure bloom's toggleable. So we kind of want to say, right, if g settings dot graphics dot exposure mode, if that is equal to auto exposure, so v0 graphics exposure mode is auto, then we poke on the lovely flag, which is graphics VK post processing auto exposure. Else, nothing. Then we carry on again to the next line. Renders in 0.07 milliseconds instead of 2 milliseconds. Flavor explains a lot of the downsides, right? Slightly low quality, yeah, I imagine because you're compressing it and that. It is very small, isn't it? Good point. That makes sense. Yeah, it's worth thinking about. Tone map, mood. GT7. Tone map, yes or no. And also, is it HDR or not? Is HDR? HDR. Lovely. Oh, I think that's fine. Cool. Nice. The other one we've got to do is there's the bloom texture, right? Now the bloom texture, we don't want this. So G settings, graphics bloom, right? If bloom is enabled, great. If not, just poke a 0 in there. That'll be good enough. I don't think it's going to like that. So no, I think we can do something like that. Just a null descriptor basically. Well, a null ID which points to the it points to the first descriptor, which is definitely not the bloom image. Put it that way. It's as good and it just works. So in the post-processing, yeah, if it's non-zero, use the bloom, right? So I think that's in a real good place. Let's try that out, shall we? So pop open the settings menu. Right, can we turn off bloom? There we go. Bloom went off, bloom on, bloom off, bloom on. Right, you can change the filter. Oh, we haven't really got the filter radius sorted out. We'll do that in a bit. So we can debug, visualize the exposure, buckets. Obviously change all that. We've seen that. Now we can turn off to manual exposure. Way overexposed. No biggie. Change the I don't think it seems to be working. It's way too overexposed still. Oh, we didn't pass in the auto exposure or manual exposure bias, did we? That's why. Silly me. So if we're on auto exposure, then we want auto exposure bias. If not, we want the other one. That makes a lot of sense. Hey, how's it going, Danzy? How you doing? Long time no see. Yeah, good to see you too. How you been? How's life going? How's life been? When you saw that build script, it's just being real bad. Right. It's just rebuilding everything. Right, so change the manual exposure. Oh, so the higher the EV. Okay, it's cool. So I think we just go to like, probably from 0 all the way to 10 we should allow, maybe. 0 to 10. And then we've got a bias. Yeah, a little bias from, that's cool, it's working, yeah, from the auto exposure. Nice. Love it. Can we turn off tone mapping? Yes, we can. Nice. We need to map in the field of view as well, but it's getting closer. So, yeah, I don't know, but like, what did we say just a second ago we was doing? So manual exposure, and that works. Oh yeah, the manual exposure range. So the range needs to change from -10. Oh, sorry, 0, +10, really. Yes. Cool. So we could wire in the FOV, the field of view. That could be quite nice. The camera field of view. So we could just, I don't know where the camera is. Guess it's in game. Yeah, so we just do G settings. Something like that. But this is on initialization. So we kind of want to change that every single frame. There's a way to like render frame or something. Everyone, thanks. Lots of travel over the past 6 months. Wow, amazing. Where else have you been? Is it just in the UK or you've been abroad? Yeah, doing good. The family's great. Yeah, doing really good, thank you. Yeah, really blessed. Lots of good things going on in my life right now. I can't really disclose too much just yet, but yeah, lots of good things happening. As you can see, I've obviously started a business now. So we've, started a Hero Studios, obviously, for our Lord and Savior Jesus Christ. Getting my life in the right order. As it says in the Bible, Matthew 6:33, but first seek the kingdom of God and his righteousness, and all these things should be added onto you. So, always a Christian, but not really seeking God first. Change now. So, seek God first, because it's the right way around to do it. But yeah. So it's been really cool. Started the business. It's a lot of faff, Running a business is faff. I got to sort out all the accountant stuff at some point. I can tell you, man. The way you got to sign up with the government, it's like scan your face, scan your documents, and you'll get the right lighting, and oh, man. And you got to tell this person you're awake, or yeah, this person you're running, and oh man, business. You can see why people make being business stuff a whole job, because it's just so much. There's laws to follow, all these things. But yeah. Exposure. Where else are we going? Yeah, the FOV. Render frame. This is what we wanted. So in the payload, when we give it the camera. Oh, my young man is crying downstairs. I think he had played a little bit too rough with his cousin. Oh boy. Go and see him in a minute. I need a drink anyway. G settings. FOV. There we go. Tweakable FOV. Lovely. Let's see that. Field of view. Bum 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 bum. Whoa, that's terrible. Well, clearly it wants to be in radians or something. What's going on? What's going on? That can't be right. What's going on? Was it really in the wrong space the whole time? There we go. Look at that. The field of view. Looking super stretched, obviously, out here because the field of view is the way it is. Cool. That's nice. Time map all works. We just got the other two on exposure now to do, so tweak the bloom, radius, and all that, I think. It's basically there. Lovely. Been self-employed for contractor of an LTD company over the past 20 years now, so if you need any pointers, just hit me up. Amazing. Thank you so much. Yeah, thank you. Appreciate it. Yeah, it's strange. You see why it's done this way. It's as if they don't want people to run their own businesses, you know, they make it hard. Make it a struggle. Make it seem so complicated. But yeah. Right, I'm just gonna take a quick break. I want to get another drink. Then we'll come back, we'll wrap up on the settings and try and stop my thing from over compiling. And then we might try and make it really nice to navigate on the keyboard, stuff like that. Right, be right back. But yeah, if you guys have any questions, feel free to ask away, by the way, in the chat. I'll happily back and answer. Right, BRB, what do I do? I think I'll just leave the code running and we'll leave my chair in charge. Ah, welcome back everyone. How are we all doing? Ah. Got myself a nice Pepsi. Got myself a Pepsi Max Cherry. Sure we've all seen this now these days. You know what, if you go to Pizza Hut, right, you can get Pepsi Vanilla. It's amazing. Oh, spill a bit of Pepsi. We got some ice as well, because you got to have it cold, right? You can't have Pepsi warm. Oh. Oh, spill Pepsi, no. Let me just get something. Do. Here we go. Right here. So we wanted to get the bloom filter radius wired up as well. Very easy one. I think we just look for to-dos, we can find it. Yeah, bloom radius setting. So that would be G settings, graphics, bloom filter radius. Oh, my boy's having too much fun. He's got his cousin over, right, and he's riding on his back. And my son's like 2.5 years old. And is fallen off twice now. Poor boy. Good fun. He's having too much fun. That's what it is. That's the thing. You have children, right? Yeah, so we'll go from 0 to 2. Start for 1. You have children, and it's always, so you want them to have fun, but there's a place where it becomes too much fun. And they end up just getting upset. For instance, sometimes you can give them like a chocolate bar or something. Not a whole one, but just a piece. Right, just to get them, just to like give them some pleasure, right? Some fun. But then they'll want more. And it's like it would just been better if you just didn't give them sometimes. Because then next now they get upset. It's funny. But yeah. Alright. Bloom filter radius. Oh crap. Man. Oh, stupid thing. Stop going. I don't want you to keep compiling. It's sad. So in post-processing as well, a bloom strength. Right, let's try that again. Please, just work once. Okay, good. Right, so here we go. So, we could do a sun direction as well, a time of day maybe. That would be nice. Or imagine if you picked a time of day and it did the sun direction. That'd be kind of cool. But then again, but yeah, bloom strength, right? How much of the bloom do you want? 0.1, please. That's the bloom I want. Filter radius. We can't really make it out too much here. But it is kind of changing. Anyway, it is working fine. Cool. I think this is in a really good place now. what shall we do next? Yeah, let's sort out the the bug in the build system. It keeps trying to build everything over and over and over again. It's horrible. Horrible bug. Luckily, we don't have to build a lot. And everything's kind of very lightweight at the moment. We probably also want to plan out the next set of work. Like, we're doing materials next. It's going to be really cool, really fun. Procedural materials, PBR, all that stuff. So we should probably spend some time to write that out and figure out sort of like what to do. So we already know what to do, but it's like kind of what order, what comes first. Right, let's fix the build system quick. So it's trying to recompile absolutely everything. Absolutely everything. It's not very nice. So a file system change would have came in, caused caused a problem. Sorry, file system change would have come in and caused everything to rebuild, kind of. But then, like, which one was it? So maybe it's one of the most earliest dependencies, which everything else is dependent on, perhaps. Don't know. So this is the Windows part of it. It just basically watches using completion ports, watches directories, but we don't. So there is a I think in update, yeah, there's a debug log. So what we can do is turn this on here, and this should help us find it out. Right. So I guess this is part of the help, right? So you're saying all of this has changed. All of it changed. Everything is changed. So it's running this because this changed. Because settings changed. Then it's running because game. So everything's just changed. Everything is supposedly changed. So I think that code. What do we changed like the timestamp checking code, was it? No, the committing code, I think it was. So when do a commit. Yeah. So I think when we read in the timestamp file, parse the timestamps, right? It's going to grab this build timestamps. Yeah, but it says the success. The success and the latest modified time are the same. That's strange. So update with. Yeah, this is on Linux. Sorry, Windows here. Yeah. So there is this update one as well. That's when you parse the deps file string. This is what deps file looks like. It's just the standard file they use on Linux, Clang. You know, to say this file is dependent on these things, we parse it, then we've got them as dependencies, right? It's quite. You can get this with all the complex, with the GCC and Clang, and you can also do your own version of this if you need to, right? So it's -md. So when you try and compile a program, it will give you all the header files and everything. So it's super nice. No. So every time you parse a depths file, right, you're then going to do an update. So you'll come across it, right, and then it's going to do an update with. So then it'll be like, hey, the file changed. So you would have done a new stat and the latest modified time. Oh, so which one is output into the file? Right, so I think that might be the problem is the commit. Sorry, not the commit, the save. Is the save even happening? Build. There is a timestamps here. Okay, so it's kind of happening. So outputs the success modified time. So one which built successfully, which is what you would expect. Okay. So I wonder why they're all saying they're changed now. We could put out the old and new. That shouldn't be too hard. I'm just confused why that would be the case though. So right, it's doing like an old time, new time type thing. T latest and then time. I guess we do the clear screen thing. Give it a run. Okay, so right, they're all got a bunch of zeros for some reason. Right, zero then the new number time, but they shouldn't have zeros, right? Because the whole point is when you read the timestamp, this thing. Well, we got a bunch of zeros in here. This is the problem. So the latest timestamp is 0. This is why. So why did it save out a 0? And it saved out 0 when it was successful. That means the commit code that we wrote, the new commit code, this did not want to work, which sucks. Okay. Our processes count equals 0 needs to come after commits count because it uses, sorry, the commit timestamps because it uses the processes in here. All right. Cool. So every single time we're sort of waiting for a barrier to be done, all the jobs to be done, we commit the timestamps afterwards for all the processes which just ran. Cool. That'll do it. Cool. And then we just basically, we can test it out working again. We can go into that post-processing and we can like just, color.r equal 1. And that's red. Ta-da! Works. Lovely. So now we're just going to the build script again and then get rid of the debug thing, right? Nice. Right, happy about that. So, we could spend a little bit of time making it a bit easier. Mars sky? What about the Mars sky? Oh, yeah. That's true, the red. I wonder what Mars sky would it be red? It might be right because of the atmosphere scattering what's on the surface. Nice. Amazing. Yeah, apparently Mars used to have water or something like that. Oh no. Cool. So I'd like to sort the settings a bit. Settings. Oh yeah, by the way, you can't paste it on Imager or IMGR, whatever you call it, because apparently it's banned in the UK now. We tried it the other day. Someone tried to send me an image and it's like, it's banned in the UK. Like you literally cannot look at pictures in the UK apparently because they're too bad. So we're in here and we can type in like exposure. This is cool, right? And then we can go here, move left and right. I don't think we need anything else. It's already working as pleased, right? Press escape, it goes back to here. We can, FOV. Cool. So yeah, I think we're fine. So we can tick that one off. I think let's think about the so if you guys saw my presentation that we did on the first time coming back. This one, the untitled presentation. Obviously we announced lots of things. Lots and lots of things. The stream is still available on Sunday the 1st of February. You can go and watch it if you want. So we've done the sky shader. Right, we've got a sky in there. We've done tone mapping. We've done the DCI-P3. Because what we do is we render in DCI-P3 and not Rec 709. And we've got bloom in there. But now it's time to do this guy. The material shading. Bum, 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 bum. So we want to do... That's right. Oh, wow. Are you telling me they could have taken this photo, but they couldn't take a photo of 3i Atlas? Oh yeah, 3i Atlas was a fun one. This is great. What's this though? Yeah, the thing that made me, die inside about 3i Atlas is you get a bunch of people who are like space nerds, right? And they always talk about space, everything to do with space, right? But 3i Atlas comes on the scenes, crickets, complete silence, because it could have something to do with aliens. So people keep their mouth shut because they don't look crazy. And everyone just gets on as if, yeah, it's pretty fun. But I tried to speak to someone about 3i Atlas, and they would actually have a talk about it, but no one would ever start the conversation about 3i Atlas because it's too conspiracy theory. Cloud, not sure if it's water vapor or not. Nice, interesting. Actually, yeah. Yeah, what other clouds would you get? Yeah, so the plan, in previous times, we did like baking textures out to disk like this, and then we rendered them, right? And they were procedurally done in shaders though, but they're just baked out to disk. Now, what I want to do is that again, but not put out to disk. Because I want to do a 3D texture, and those are too much memory. Because we want to try and procedurally texture an SDF. So the basic idea would be to take a 3D coordinate and then probably have some noise textures that you can sample from, right? Because those would be cheap, maybe. Or maybe noise textures that you can sample from. Oh yeah, maybe. Yeah, because you want to have something which you can pull from memory that's already pre-computed, because that saves time. But sometimes you might do some cheap noise functions, maybe, I don't know. But the idea is to do it all at runtime using shader code for everything. So do like, dirt, sand, grass or whatever, right? Metal, rock, all at runtime. So it is a bit risky. So what we're going to try and do is do it first, right? We've got the HDR content in like the sky. So we want before we do meshes, we want to basically just test out full screen material shading. How quick can it work? So we want to do full PBR, but rather than we want to have material layers as well. So we could basically have a cheap dirt shader and a cheap rock shader, and then do layers of materials which are just basically blended together, right? So you could do albedo, metal, and roughness. That's the classical PBR that people do. But the problem is when you PBR metal, PBR metal versus specular. Come on. There's a thing for it. Is this the one? No, it's not got the gun. There's a blog on it somewhere. So the basic idea is, yeah, so there's two PBR workflows. There's the albedo, roughness, metallic, or there's diffuse, glossiness, specular. Roughness and glossiness are the same thing, except for glossiness is one take roughness, and roughness is one take glossiness, right? It's just inverted the other way around. Diffuse, and so then diffuse and specular are full colors, right? So you define a color for them, and albedo is a full color, but metallic is just a floating point value. Now you use the metallic to get the specular color in the shader code. Like for instance, on dielectric materials, so that's non-metals, so plastics and stuff like that, the specular color is just going to be gray, right? A very soft gray, like a very 0.04 or something like that. I forget what it is exactly. It's just a gray. Whereas on a metal, the color is the color would for the specular color, that would be the hang on a minute. Specular color. That'd be the surface color basically. So it will have no diffuse. So for metals, it will have no diffuse, but the albedo will be the specular color. It's something like that. Now, the reason why we want to use this one, which is the sort of not really, Unreal Engine and that use this one at the top, and we was using this, but we want to switch to this one. And the reason is because material layers. So when it comes to blending metal, when you blend the metal and its parameter, so if you have a material layer which is metal and material layer which is non-metal, when you blend those two together, you can get an in-between, and you'll start to get artifacts like weird edges because it just doesn't blend as well as color information does. Basically, you're blending a value of metal which gets turned into, it just doesn't blend as well. I can't really explain it as well. But the issue with doing it this way is you have to define your colors in that manually, I think. So it means that you could create physically incorrect materials. But I guess since we're doing the editor in the game anyway, or the game engine, you could probably make it you could probably have a physically correct mode and just basically say, well, if this is a metal, we can only, you know, maybe, yeah, I'm not sure how we could do it, but maybe we store it as this, but maybe we give the interface as this. I'm not sure. We'll see. We'll see. Yeah, inverse, yep. Not grey necessarily. The color is reflected light, but without tinting of the light. Yes. Yeah. So the metals don't absorb the light. Metals completely reflect. There's no refraction where it goes into the surface. Yeah. While metals does tint the reflected light. Yeah. That's right. So dielectrics don't tint the reflected light, but metals do because it's a pure reflection. Yeah, exactly. So that's why you need the yeah. Whereas like a dielectric, like a plastic or something, it will sort of bounce around in the object, if you will. Come back out again, maybe. You get that sort of thing. But yeah, right, cool. So I can't find the thing for it, but basically maybe it's on images. There's pictures of like the blending of them basically. It gets artifacts. It looks horrible, like when you blend non-metals and metals. This is it. This is the picture I'm looking for. This is the blog post. Oh, no. No, this is not the blog post, but it's got the picture that I want. Yeah, so if you use the specular map workflow, like he's trying to put this sort of like wear on the gun or whatever, and it's probably like a non-metal or something like that, but it shows up. So that's just wear. But as you see, there's these sort of artifacts here where you can see it's like a highlight around where the metal and the non-metal meet, kind of thing, which is wrong. So when you do layering of materials and blending, you'll get these artifacts. So we want to avoid that, so we use this specular map workflow. So that's the basic idea. So I think what we can do, let's see if we can plan this out a little bit. Documentation. Yeah, so I guess we'll just say open. Oh, right. Open docs. Materials plan. Okay, so we'll basically just say, you know, I've got some of it here anyway. So I guess the sort of first thing we would like to do, we should try and break this down to like streams, right? What stream? One stream do this, one stream do that. So one of them is like we want to do material we actually want to do like PBR. You know, specular gloss. Specular gloss. Now, we do want to make sure that we break them into these little programs though. Like have an actual like graphics shade thing. Crap. Yeah, no. This comes later. Yeah, so we do like diffuse gloss workflow, where we just want to basically say, you know, hard-coded, specular, so diffuse, specular gloss values. All right, we're just getting the thing working. We do the whole sort of like, so we maybe have a directional light, which is the sun, right? So that, you know, just the directional light which lights up the surface that we put down. Maybe we just do a ball or something like this. I don't know, what's a sensible idea? Should we do a cube? Yeah, people typically do those ball, you know, there's that sort of material ball as they call it, isn't it? This is the trendy thing to do. Call it material ball. But yeah. So it basically just has but I don't know. We could just get a sphere. We don't really have a so we could do a mesh. So we can render our mesh. Just a cube. Render a cube. And then put in, and then when we shade it, hard-coded values, and just basically make it a sphere. Maybe ray march it. I don't know what's the easiest thing to do, but it would be nice if we had like a sphere, wouldn't it? Because a sphere actually has yeah, it's rounded, but or we could just do a cube. I think let's just do a cube because it's the simplest. Yeah. So we'll probably just say like, you know, cube mesh. Very simple one. Just so we can get up running. A directional light. Very easy to chuck in. And what else do we need? We need to check against the... Oh, I just realized our sky map does not do the pre-filter stuff, where it pre-filters the sky map. That's going to be a bit of a problem. That makes it even more computational as well. But yeah, so we've got like a... So the sky map that we have needs to be pre-filtered such that there's a thing on OpenGL. Whereas when you have a roughness, you need like a cone of you need to when you sample the sky map, you need to take a cone and sort of downsample that area, if you will, to get the reflection in the metals, right? So I think we'll call this the yeah. We basically want a way to yeah. So this will come afterwards. We need to basically do the sky map pre-filter. I think it's called. And maybe it's called the diffuse. Something like that. Sphere is good at testing because it does all the combination of incoming light and outgoing light. True. Yeah, right, let's just do a sphere. We'll do, we could ray march it might be easier to do that. A cube mesh, then hard code, a quick, you know, ray marcher or something like that, or rayverse sphere, in the pixel shader, in the in the pixel shader, something like that. and slash visibility shade. Yeah, visibility buffer shade. Yep, good point. Yep, good point. And I can rotate the camera and all that around the sphere. Right, change the time of day. So learn OpenGL. It's got this like pre-filter map. The light maps. It's probably the lighting. Image-based lighting, diffuser radiance, and specular image-based. We want to do one of these basically. So it's a special downsample blur thing. I've already got the code in the previous project for this, but yeah, we can port that over from the old project. There we go. So SkyMap, that should be done in a stream as well. So this is for specular and diffuse lighting, basically. So sorry, for specular lighting diffuse lighting for specular reflections. But it obviously doesn't take the reflections of the scene, it takes the reflection of just the sky. If you want to do reflections of the scene, that becomes some other thing. It's all things to add in. You can do like screen space reflections, you can do, tracing against another acceleration structure and stuff like this. But you always do the cheapest first, right? But yeah, it's one of these things. What else? So yeah, if we get that specular gloss in first, then we can get the scene showing up in the actual object. The lighting, make that actually work. PBR work fine. And then we could probably start from then doing all this material shading thing. So we probably then want to add the concept of a proto material, which is basically saying a shader, a piece of shader code with some property definitions. And then a material is it references a proto material and it provides the properties. So you can configure these shaders at runtime, which is kind of cool. Now, what we probably would like to do is provide. Yeah, so I think at this point we might do. This is doing the actual, proto materials. This is actually doing the procedural material shading. So this is a big one, but hopefully we can break it down enough. So this would be, we want this stuff basically. So yeah, there'll be very simple ones to start off with, like, hey, this is a red shader, all right? But we can make it become dirt and stuff like that as we go. So pro material, which is shader code plus definitions. Then material layers. So each triangle has up to 4. We won't be able to get it as each triangle up to 4 per se. In this case, maybe. No, maybe we can. So we can do the Rayverse sphere intersection, and then depending on which face of the cube you have different material properties. We could do that. You have the sort of this side and the other side, and then we can test them all out, spinning it around. That would be cool. So we could say, test out where each side of the cube or the sphere has different material layers, different sets of material layers, right? Nice. Diffuse specular gloss. We've already got that in there at this point, so we delete that for better blending. Yep, we can also do more physically incorrect. That's cool if we want. Right, define this sort of like graphic materials.h. Some structure in there. So this PBR, it's got the diffuse, specular, etc., etc. And then we have this sort of like shade function, which takes in a three-dimensional, excuse me, a three-dimensional UV, the proto material to run, so it was, you know, switch, and then obviously all the properties will be in an array, and it's the job of the code that runs in here to decode from that word buffer, right? The property word buffer. Now, we obviously want to make sure there's certain things where we want to make sure we only run this, all threads within the same wave, so 32 threads that run in lockstep, they all run the same proto material. There's stuff we can do to sort that out. Don't worry about that one. But we're just going to make sure every time we call this, it has to be within the same wave. Now, we probably also want to add support for, so here we'll probably have like a super basic, yeah, so not this at some material layers. Yeah, we won't actually get that done just, I'm trying to think how much I can do in a stream just to get going. We could probably get the most basic one. Yeah, we could. And then we probably want to add support for like noise. I don't know though. Maybe like noise. Yeah, I guess we can say, you know, work on, you know, work on dirt or make dirt. But you know what I mean? Like make different materials maybe. Because at this point we would, all we have it basically there. So yeah, there's all this stuff as well. This is the visibility buffer shade. It's gonna have to change a bit, but that's cool. We can get that as well. Read visibility buffer, find triangle. Let's just drop this in here. Excuse me. Yeah, so something like this. So it's just some notes, basically. Leap over all that. Additive blend, advance to next layer. Cool, lovely, lovely, lovely. Now the next one would be basically, you know, make some custom materials. Now these ones, we do want to do a full screen pass at some point as well to really test how good it is, how bad it is. Maybe we just basically duplicate all of the spheres across the whole screen. That's another way to do it. But yeah, so we also want to add support for different materials. Has anyone got any good examples of materials that we can do? Bricks seems quite easy to do. Maybe a bit of dirt as well. It's just some noise. So sand, really. I don't know about grass, but we obviously need like a metal. Sorry, so make some materials, right? So proto materials, right? So actual shader code. So we'll probably do like, you know, a brick will be nice and easy, and also like a dirt. Maybe like a sand. Maybe like some kind of metal. Don't know which ones. Could you do like a copper gold. What's another one? Like a tin or something. Or steel. But yeah, just some ideas, stuff like this, right? Maybe too many metals, but you get the gist. Now, one thing we want to be careful of, or to consider about, should I say, is these materials. The advantage of doing them at runtime is the properties can change at runtime. So we maybe want to have ways in which you can have many instances of these things. I don't know, but you kind of also want to share the same material data because the more that fits into cache, the better, right? So yeah, it's an interesting thing to think about. Yeah, one more thing as well was like turn lead into gold. Hey, Captain, how you doing? Lead. Is that a joke I'm missing? Hang on a minute. How you been? Oh yeah, I want to do the full screen pass, isn't it? So yeah, maybe we do a full screen. Yeah, we don't have to just do one mesh. We could probably say, you know, make a floor covered with these things. Or maybe we can do a cube as well that just covers the whole area purely for make a grid of these to test performance. Or not even that. You don't really even need a grid. Oh yeah, maybe you need a grid of them to test performance, and then you just basically put a camera position. Maybe 3x3 at most, maybe 3x3 at most, and you want to like test. Make camera go over. Make camera view these spheres at full screen. So as many pixels will be shaded. I was just thinking of materials change, runtime changing, though, of that domino. Thought of that domino. No, it's not really. Yeah, so glass it will be a bit more complicated because we need transparency. Yeah, you could do. There's a few ways you can cheat in, but I've got a deferred render at the moment, so like a visibility buffer. So you just render the opaque stuff first, and then later on, you just render out mesh IDs and triangle IDs basically into a texture, and then later on you shade it, right? So to do layers of that, like transparency, you need to do a forward renderer afterwards, maybe. We'll have to see which way we go around that. But yeah. Luckily, we might not have to do too much glass. Actually, we might have to. But yeah. Yeah, changing runtime materials at runtime isn't a bad idea. I'm not sure if we would actually need it though. But it'll be a good capability to have since it's you know, is one of the underlying properties of, or strengths, underlying strengths of this solution. So we should make that work well. I'm just trying to think, like, why would, yeah, I think we basically want to try and get as much reuse as possible. Maybe we could do a reference count type thing. But yeah, so like something from the game side would have to basically say, yeah, so you could probably have materials which actually exist on the file system. They're like encoded into using the encoder system. And you just basically read the properties in, right? And they're just like passed to the renderer or whatever, and they're just loaded in. Then you can probably then have some extra sliders where it's like, you see, that's the thing. It's like, imagine if you had gold, and then you might want to layer on top where you make it like dirty or something like that. But then maybe is that just like another material layer rather than being a property of the actual like gold shader, right? So the gold material shader should just output gold and it should just look like gold. But if you want to put any sort of like roughness over it or something like that, maybe. Yeah, see, that's another interesting thing, isn't it? It's like you might want to literally have like a sort of like a roughness proto material where you just basically put on that, you know, or not even that, just like a wear. Is that how you write it? Right, so you're putting wear on to sand, wear. I don't know if you put wear onto dirt, it doesn't make that much sense. But you can put wear onto copper maybe, and it can blend on top, you know. But I wonder if the wear might look different depending on each material though, you know. Maybe there's like a metal wear, but then brick it might need something different. But yeah, it's stuff to think about. Because you can't, you know, I guess you could put like per pixel you could do like roughness, but then you could put maybe there's AO in there as well, you know. Baked AO. Hey Ref, how you doing, sir? How's things going? Yeah, so maybe there's some interesting ideas we could do is that maybe wear on top to make something look like it's worn. And what's another word for that? Synonym. Erode. There was another one where it's like, oh, a crumble. Crumble shader. A crumble material. Yeah, anyways. Stuff to think about. Yeah, I think this is pretty reasonable. So this would be pretty cool. So I guess, when's the next stream? It's Sunday, isn't it? Yeah, we've got a timetable down below, guys. You can check when we next stream. But the next one is probably doing this PBR specular gloss. We'll get a nice little mesh. We'll quickly ray sphere intersect it so we make it a sphere-like without outputting a bunch of vertices and stuff. Get a little grid of them, right? Get a little camera view so you can see them all full kind of screen, you know, top down maybe. And we maybe want to make the sun light. Maybe make the time of day, you know, expose time of day inside the settings panel. Right, it'd be nice and easy to do, and it will be very helpful for this. But I have to keep going in and tweaking it. And then, yes, that's one stream. Then select the sky map pre-filter so we can get the reflections looking nice with our lovely sky map that we got. So with a sky map, when we have a material, it should show obviously in there the the material here. Oh, I forgot about that. We need to get the exposure adjusting speed. But anyway, stuff to think about. Yeah, and then obviously procedural material shading, actually getting that whole system in. It might take a couple of streams to do this. And then just actually have some fun, make some materials and test some performance. This is the plan. Hope you're going to enjoy it. We're starting at Sunday stream. There's a stream on Tuesday, stream on Thursday, stream next Friday as well. There's a Discord if you come and hang out in the meantime. And oh, there's also, if you'd like to support the channel and get access to the code on your machine, you can support us via Ko-Fi, £5 a month membership. You can get it 1 month, cancel it the next month. It's up to you, whatever. But it's there if you want to get access to it, run it on your local machine, and also support the channel in the meantime as well. And there is also a YouTube channel as well. It's the same name on YouTube if you want to follow that. The VODs go up there forever, basically. But yeah, thank you all for coming. I hope you all have a good weekend, and I'll see you all on Sunday, hopefully. And yeah, appreciate your support, guys. I'll wait, my face is off the screen. Here we go. I'll see you all soon. Bye bye.